Okay, so everybody, welcome back to lecture 2 of our Math 2 series. Today we'll be talking about solving quadratic equations by factoring. All right, for those of you that are new, I know that it says lecture, but feel free to interact with me. There'll be times I'll be pausing for questions, or like asking you guys if you could answer a question for me. So don't be shy. Go ahead and feel free to interact. All right. With that being said, let's go ahead and get started. So let's break this apart. So first of all, when we say a quadratic equation, we're talking about pretty much any equation that has an x squared term in it. So if I have x squared plus something else equals 0, or some other number, that's a quadratic equation. And one of the ways we can solve this quadratic equation is by factoring. So before we go any further, let's review what factors are. Basically, a factor is a number or expression that can be multiplied by another number or expression to get what we started with. Let me make that a little bit smaller. So for example, let's take it back for a second. What if I just ask for like factors of 21? There I would basically just be asking what numbers can I multiply together to get 20? That'll help me get 21. So like for example, I can multiply 1 by 21 and get 21. I can also multiply 3 by 7 and get 21. Or with something like x squared plus 5x plus 6, we're going to go more into detail about how I figured this out in a second. But I could take the expression x plus 2 and multiply by the expression x plus 3. And if I multiply this back out using my FOIL method, so multiplying the first terms, then the outer terms, then the inner terms, then the last terms, let's see what we get. So multiplying the first terms together, x times x gives me x squared. Outer, so multiplying the first term and the outer term, I get 3x. Inner, so if I multiply the 2 and the x together, I get 2x. And last, so if I multiply the 2 and the 3, I get 6. And then if I combine like terms, so if I add the 3x and the 2x together, I get that x squared plus 5x plus 6, which, hey, is what I started with. So we can use the fact that we can factor quadratic equations to help us solve them, and we'll be getting more in detail about that after we review what factoring is. Does anyone have any questions so far? Does anyone need a review of like multiplying binomials or distributive property or anything that we've like gone over so far in the lecture?
No, I'm good.
Okay. All right. If no one else has anything they wanted to add, let's go ahead and move on. All right. Let's see. So we're going to start from the easiest type of factoring and kind of work our way up. And so we've reviewed all those types of factoring you might see in a Math 2 class, and then we start actually solving equations. So the most simple type of factoring there is factoring out a greatest common factor, which basically means that I'm going to look at all of the terms in my quadratic expression, or I guess in this case in my expression, whatever it is, and see what's the biggest number or biggest thing that I can pull out. So, like for example, in number 1, if I look at 8 and 6x to the 4th, the biggest thing that I can pull out, or in other words, the biggest thing that I can divide 8 and 6x to the 4th by evenly is 2. And on the inside, I'll be left with 4 plus 3x to the 4th. Which makes sense because I know that 2 times 4, if I distributed that would get me the 8. And 2 times 3x to the 4th, if I multiply 2 by 3, that gets me 6. And then there's no other variable, so then multiplying nothing by x to the 4th would get me x to the 4th. Same thing in number 2. If I look between 2n and 4, again, I can just pull out a 2. And so that'll leave me left with n minus 2. Okay, what about number 3? Can anyone tell me what the greatest common factor I can pull out of the terms in 3 is?
Four?
Yeah, good, 4. So if I'm looking at the numbers, I can pull out a 4. Can I pull out, but I also noticed that one term has an n to the 9th and one term has an n. Can I pull anything else out besides just the number 4? What about the letter n too? Okay, so 4n times what gets me 4n to the 9th? Anybody? And into the 8th.
And 8.
And then 4n times 3 would get me 12n. All right, let's do through, say, number 6. Then we're going to move on to the next type of factoring. This isn't that bad. This should be, hopefully this should be a review from everybody from Math 1. So 3r and 9. What's the biggest thing I can pull out of 3r and 9? A 3. Okay, so I'm going to pull a 3 out. 3 times r gives me 3r, and 3 times 3 gives me 9. So I'm left with 3 times r plus 3. Okay, a couple more, then we're going to go ahead and move on to the next type. So negative 12a minus 3. I could pull out a negative 3 or a 3. I just kind of like, since both of these have minus signs, I just like to pull out a negative whenever that's true. And so I know that negative 3 times 4a will get me negative 12a, and negative 3 times positive 1 will get me negative 3 there. Okay, and just to wrap it up, number 6. Who can tell me what I can pull out of 5r and 4r to the 4th? Notice that between 5r and 4r to the 4th, 5 and 4 don't have any common factors that we can pull out, but we can pull out an r. And so then I'm on the inside, I'm left with 5 plus 4r to the 3rd. Okay, that's the first type of factoring. Very simple. Should be a review from Math 1 for most of y'all. Does anyone have any questions?
No.
Okay, let's go ahead and move on. All right, so I'm just going to save this for later. Okay, and we're going to move on to the next site. Okay. So the next thing we're going to do is we're going to talk about factoring when we don't have a leading coefficient. In other words, how do I factor if I have 3 terms here, like for example, in number 1, b squared, an 8b, and a 7, 3 terms. And out front, I don't have anything that I'm necessarily starting with. It's just sort of b squared out by itself. There's no there's no 2b squared or 3b squared or anything like that. So basically all I'm gonna do for this is I need to find 2 numbers that multiply to give me the number on the end. So multiply to give me 7. And I want when I add these 2 numbers that their sum gives me the coefficient in the middle. So the sum should be equal to 8. So let's see. Well, 7's a prime number. So I know the only 2 numbers I can multiply together to get me 7 are 1 and 7. And I know that if I take 1 plus 7, that gives me 8. So if I wanted to factor this, it would just be b plus 1 and b plus 7. All right, so again, I'm going to FOIL this. So multiplying my first terms together, I end up with b squared. My outer terms, I end up with 7b. Multiplying my inner terms, I end up with 1b. And multiplying my last terms, I end up with 7. Which, if we combine like terms, notice I can combine the 7b and the 1b. So I end up with b squared plus 8b plus 7, which is what I wanted, because I wanted when I multiply my factors back out to get with what I started. Okay, looking at number 2, I want to find 2 numbers that multiply to give me positive 10. And when I add them together, give me negative 11. Well, let's see. I know that it's 2 numbers that multiply to give me a positive. So that's either going to be a positive number and a positive number, or a negative number and a negative number. I can't be a positive number times a negative number, because a positive times a negative will give me a negative. And since I know that when I add these 2 numbers, I get a negative number, that's a sign to me that both these numbers are going to, whatever they are going to be negative. So thinking about 2 numbers that would multiply together to give me 10 and add together to give me negative 11. Well, for argument's sake, let's say for first thing I wanted to guess was negative 2 and negative Well, let's see. -2 plus -5 gives me -7, which is not what I want. So I would keep going. So the only other option I have, -1 and -10, which I know would work because -1 plus -10 equals -11. So once again, just like in the last problem, I'm basically just going to attach those two numbers to ends. And I'm done. Okay, what about number 3, where I'm trying to find two numbers that multiply to be -90 and add to be, well, I don't see a number out in front of the middle term, which is m in this case. So I just want the sum in that case to be equal to 1. Because remember, when we don't see any coefficient in front of our term, we assume that the coefficient or the number that's supposed to be out in front is 1. Okay, so two numbers that multiply to give me -90 and add to be 1. Well, from what I know about like multiplying integers, I know that in order to get multiply and get a negative number, I have to multiply a positive number by a negative number. So one number is going to be positive and the other is going to be negative. In this case, it's going to be +10 and -9, which makes sense because if I add +10 and -9, I get 1. So once again, I'm just going to slap some m's on there. So m plus 10 and m minus 9. All right, does anyone have any questions so far? Okay. Let's go ahead and go through number 6, and then we're going to talk about the next type of factoring. This should also be like a review, so hopefully no one's having like too much trouble so far. Okay, so number 4, I'm trying to find two numbers that multiply to give me -12, that number on the end right there, and that add to give me +4, that number in the middle. So let's see, if I'm trying to find two numbers that multiply to give me -12 and add to give me 4, anyone have any idea what that might be? Well, if you thought 6 and -2, you'd be exactly right. Oh. Okay, what about number 5? I'm trying to find two numbers that multiply to give me +9, and if I add them together, give me -10. So there I go again. I need two numbers that multiply to give me a positive number. So I know the signs are going to be the same, but they have to add to give me a negative number. So I know that both of them are going to be negative. And the only two numbers that'll work are -1 and -9. Because if I add -1 and -9, I get -10. Why do I like the number 2 today? I don't know. Okay. Okay, one more, then we'll talk about something else. So number 6, I'm trying to find two numbers that multiply to give me 64, add to give me this coefficient in the middle, which is 16. All right, so then that's 8 and 8, because I know that 8 plus 8 is 16. So then, because I'm dealing with b's, I'm just going to say b plus 8 times b plus 8. And I'm good. All right, anyone have any questions on that before we move to the next type of factoring?
No.
All right, let's go ahead and move on then. Ooh. Okay, so the next type of factoring we're going to review is factoring a difference of squares. So with differences of squares in general, like let's say for example, I had something squared minus something squared, right? Basically what I want to do to factor this is I'm going to take the square root of both of them. So the square root of a squared would just be a, and the square root of b squared would just be b. And then I'm going to put a plus here and a minus here. And this, so basically I take the square root of my first term, take the square root of my second term, and if I add them together and then multiply by subtracting them together, it'll always end up getting me a squared plus minus b squared again. And I'll show you why in a second as we look at number 1. Okay. So looking at number 1, it's asking me to factor each of these completely. So I want to take the square root of 9x squared and the square root of 1. So the square root of 9x squared, well, I know the square root of 9 is 3, and I know that the square root of x squared is x. And the square root of 1 I know is just 1. And then I just add in my plus and my minus, and I'm good. All right. What about the question is, how do we know this works though? So once again, I'm going to go ahead and FOIL this out. So I'm going to multiply my first terms together. So 9x squared. My outer terms together, minus 3x. My inner terms together, so plus 3x. And my last terms together, so minus 1. Notice that the negative 3x and the positive 3x cancel each other out, because I know that negative 3x plus 3x is just 0, which doesn't do anything. Thus leaving me with what I started with, 9x squared minus 1. And that'll be true anytime we have two perfect squares that we're subtracting from each other. However, if we take a look at questions like 14 and 15, this does not work if I have two perfect squares that I'm adding together. So because I have two perfect squares, but because I'm adding them together, because there's a plus sign in here, I'm just going to say that that is not factorable. In other words, I can't break it any further apart than it's already been broken up. Same with 15. Because I'm adding 25x squared and 16y squared, even though I could find the square root of both of those, I'm going to say that this is not factorable either. Okay, let's go ahead. I want to do a few more on this page, and then we'll talk about the last type of factoring, which is also the trickiest type of factoring. That's factoring when we have, and that's factoring when we have a coefficient out front besides 1. But okay. So 4n squared minus 49. Can anyone tell me what the square root of 4n squared would be?
$2n.
Yeah, good. And what about the square root of 49? Yep, I know you're all thinking 7. 7 times 7 makes 49. Then I just add my plus and my minus, and I'm done. All right, number 3. So the square root of 36k squared gives me 6k. The square root of 1 is 1. Then I have a plus here and a minus, and I'm good. Number 4, square root of p squared is just p. Square root of 36 is 6. I add a plus, I add a minus, and I'm done. Number 5. So if you notice, neither 2x squared nor 18 are perfect squares, right? Like I can't easily take the square root of either of those things and get something with a whole number or something with a whole number and a variable back. Notice though that with 2x squared and negative 18, I can factor something out. Like I can take something out of both of those terms. What is it?
2x. Just 2, sorry. 2.
Yeah, no worries. Yeah, exactly. I can take a 2 out. And that'll leave me with x squared minus 9. And x squared minus 9 is a difference of perfect squares. So then I can just factor that like I've been factoring. So it ends up being 2 times x plus 3 times x minus 3. Okay, let's do one more like that. And then we're going to go ahead and move on to our last type of factoring. I'm not going to do 6 because it looks gross. We could sit here and think about like what the GCF of 196 and 144 would be, but it's like I don't, unless your teacher's kind of sadistic, I don't think they're actually going to ask that on the test. But one, I could see one like number 10 being fair game for a test. So what could we factor out of 20a squared and 45?
A 5.
Yeah, good. And that's going to leave me with 4a squared minus 9, which I could then factor to be 5 times 2a plus 3 times 2a minus 3. All right, does anyone have any questions on factoring differences of squares? All right, cool. All right, so for those of you that are in Math 2, all of that should have been a review or like look vaguely familiar from last year. But now we're going to move into a type of factoring that might be a little bit new this year because most Math 1 teachers kind of avoid it just because it's a bit trickier and it's not really in the Math 1 curriculum. It doesn't really come up in the curriculum until students get to Math 2. And that is, how do we factor when I can't pull a GCF out, but there's still a number greater than 1 out front here? Okay. This is going to take up a lot of space, so I'm just going to do the odds on this page. Y'all are welcome to do the evens on your own time, if you so wish. Again, I'm going to like attach the folder with all of these files and like all the annotations that I'm making to each file at the end of the lecture. Okay, so to start off, I'm trying to find two numbers that multiply to give me 3 times -5. Yeah, I don't like that 3. Or -15. And I want their sum to be -2. So strangely enough, we actually already kind of gave away the answer. The answer is going to be 3 and -5 because if I add 3 and -5, that just makes -2. What kind of plus sign is that? Okay. So normally at this point, like I could just slap a 3 on a P and a -5 on a P and I'd be done, right? But I'm actually not going to use those numbers to do that. I'm actually going to use those numbers, well, because I know that 3P plus -5P gives me -2P. I'm going to use the 3 and the -5 to split up my -2P. Next, I'm going to group these first two terms together and the second two terms together. Okay, now looking at the first two terms, what can I pull out of 3P squared and 3P?
Three P.
Yeah, exactly. And I'm going to be left with P plus 1 on the inside. All right, and then out of -5P and -5, I can pull out a -5. Which would again leave me with a P plus 1 on the inside. So notice that I essentially have 3P P plus 1s over here, and then -5P plus 1s over here. So I'm just gonna, last thing I'm gonna do is I'm just gonna join those two together. So 3P minus 5 times P plus 1. And I'm done. If I wanted to check that, like I said, I'm just gonna do the odds for now. Well, let's see, 3P minus 5 times P plus 1. I'm going to FOIL. So first, multiplying 3P by P gives me 3P squared. Outer. So multiplying 3P by 1 gives me 3P. Inner. So multiplying -5 by P gives me -5P. And last. So multiplying -5 by 1 gives me -5. And I'm just going to combine like terms. So 3P minus 5P gives me -2P. So 3P squared minus 2P minus 5. And I'm good. All right, let's go ahead. We're going to do 3 and 5. Ugh, and then if you look at 7, I don't really want to try and find two numbers that multiply to give me 7 times 28 and add to be 53. So we're just going to go ahead and get into actually using this to solve after that. Okay. So looking at 3n squared minus 8n plus 4, I'm trying to find two numbers that multiply to give me 3 times 4. Or in other words, multiply to give me 12. Oh my gosh. And I'm getting that just because 12, because I'm just multiplying my leading coefficient by my number that's on the end, my constant. So they have to multiply to give me 12 and add to give me -8. I'm going to sit back and think about that for a second. If anyone thinks of anything, let me know. All right, got it. It's -2 and -6. -2 plus -6 is -8. So then again, I'm not gonna just slap it on a -2 or -6 onto my ends. I'm gonna use that to split up my -8 in because I know that -2n minus 6n gives me -8n. So 3n squared minus 2n minus 6n plus 4. Okay. So next I'm going to group these two terms together and my last two terms together. So then that leaves me with, if I look at 3n squared and 2n, I can't take any numbers out, but I can take out an n. I'm left with 3n minus 2 on the inside. And over here, since I start with the -6n, typically if the third term starts with a negative, I know I'm going to pull a negative out. And then between 6n and 4, the GCF of those is 2, so I'm going to also pull a 2 out and be left with 3n minus 2. Because remember that if I left this 2 as positive, I'd get -2 times +2, which will give me -4, which I don't want. So I need to make, so since I'm pulling a -2 out, I want to also make this a -2, because -2 times -2 will give me a +4 back here. So once again, I have n groups of 3 and minus 2, n minus 2, minus 2 n groups of 3 and minus 2, which I can put together to get this as my final answer. Oh, there we go. Okay, last one. So I'm trying to find two numbers that give me 2 times 5, which I know is 10. Again, I'm getting that because this is the constant and this is my leading coefficient. And that sum to give me 11. All right, so can anyone think of two numbers that multiply to give me 10 and add to give me 11?
10 times 1.
Perfect. Okay, so then we're going to break apart our 11b using 10 and 1.
You have to hold it down while you're talking.
All right, then I'm going to group my first two terms together and my second two terms together. All right, and does anyone know what I can pull out of 2b squared and 10b? What can I pull out of 2 and 10? Yeah, right, I can pull a 2 out. Then out of b squared and v, I can also pull a v out. And then on the inside, I'm going to be left with v plus 5. Notice that there's no common factors between v and 5. So whenever that happens, I'm just going to pull a 1 out. since I know that 1 times anything is still that thing, right? Then I have 2 v groups of v plus 5 plus another group of v plus 5. So overall, I have 2v plus 1 times v plus 5 as my answer. Okay, does anyone have any questions?
Nope.
All right, moving on. Okay, so since we're doing pretty good on time, I want to go ahead and see how y'all do if we mix this all up. Oh, whoops, that's not what I meant to pull. Not yet, anyway. Okay, so I'm going to give everyone a few minutes to look at just the first 6 problems. And, you know, so like that are using like the various techniques we talked about today. And I want to see what everyone thinks when I come back from getting some water. So everyone take about 5 minutes and we'll go over these once I get back. Okay, so welcome back. Who can tell me the answer for number 1? Okay, I guess everyone's feeling a little quiet today. So number one would be x minus 9 times x plus 2. Because I know that negative 9 plus 2 gives me my number in the middle. It gives me that negative 7 that I want. Okay. Number 2.
-7 and +2.
Yep, good. So then my final answer is going to be p minus 7 plus 2. All right, what about number 3?
-8 and -1.
Nice. So n minus 1, n minus 8. Number 4.
I didn't get this one.
Yeah, no worries. -7 and -9. If I add -7 and -9, that would give me -16. And I know that 7 times 9 gives me 63. All right, 5. Now that I look at it, it's a bit more complicated. So we're going to go over that together in a second. But let's go ahead and knock 6 out first. So 7k squared plus 9k. I could factor out a k, and then I'm just left with 7k plus 9. Since there's no number I can pull out of 7k or not, it's k squared or 9k, I'm just going to leave the coefficient for k blank. All right, 5, we're dealing with some pretty big numbers. So let's just break it up piece by piece. So first, I'm trying to find two numbers that multiply to give me -140, good gosh, and add to give me -31. All right, so again, hopefully your teacher's not going to give you numbers that are this big, or if they do, you'll have a calculator. But the answer is -35 and +4. Feel free to pull out a calculator and check me on that. But we can figure out pretty easily that -35 plus 4 gives me -31. So then from there, I'm going to break apart my middle term based off of that. 7x squared minus 35x plus 4x minus 20. Then I'm going to group my first two and last two terms together. Out of the first two terms, I can take out a 7x, which leaves me with x minus 5. And out of the last two terms, I can pull out a 4, which leaves me again with x minus 5. So then my final answer, would be 7x plus 4 times x minus 5. Yeah, those a greater than 1 problems can get tricky. If anyone has like a graphing calculator, like easy access to them, sometimes one trick that I typically show my students, like when I'm teaching this at the center, is that, granted, I learned like with a high school teacher that I worked with back when I was a tutor up at Wakefield. If you go into the y equals part of your calculator, I'll pull up a new whiteboard to show you all this. But if you go into y equals, right? Like let's say I wanted the factors of 140, for instance. I could type in the y equals 140 over x, which basically just going to divide 140 by a bunch of different things. And then I can kind of just hit second, graph, and that would take me to a table where I'd end up seeing a bunch of factors. So like, you basically see a table look like this, like 1, 140, 2, 70, 3, whatever 140 over 3 is, 4, 35, 5, 28, and so on. And you could just kind of use that to try and find factors that would work. So yeah, just a calculator trick, just in case you do encounter any big numbers that you need to find the factors of quickly. Okay. So now that we've all had a chance to practice our factoring, let's talk about how we can actually use factoring to help us solve quadratic equations. So in order to understand that, we need to talk about something called the zero product problem. All right, so let me ask y'all a question. What is, don't strain yourself too hard, 0 times 5? Yeah, 0. What about 0 times 100?
0.
What about 0 times a billion?
0.
Because anything times 0 is just 0, right? So basically what the zero product property tells me is that, let's say I have two factors together, right? Like, let's say it was, let's say I have my equation, I'm doing my math, and I end up with something like x minus 2 times x minus 5 equals 0. Well, I know that if x minus 2 is equal to 0, it doesn't really matter what x minus 5 is. It would make, that would, if this is 0, the whole left side is going to be 0, right? Same with x minus 5. Like if x minus 5 is equal to 0, it doesn't really matter what x minus 2 is. Whatever I'm multiplying by just ends up being 0. So as long as either of these is equal to 0, it's going to, oh my gosh. So as long as either of these is equal to 0, it's going to make my whole equation equal to 0. So typically from there, I can just set each factor equal to 0. And I would get x equals 2 and x equals 5 as my two answers. Oh, something important to know about quadratic equations. This is going to become more important as we move on in the lecture series. Like when we start talking about like how we solve what we can't factor, or but quadratic equations are always going to have two answers. You can get the same answer twice, but you always need to have two answers. So if you do your problem, you get one answer. Again, it can be the same number twice. That's okay. Just as long as at the end you always end up with two. All right. And with that being said, let's go ahead and get into it. Okay. So for the rest of the time, we're just going to run through the odds on this page. And we should have enough time that we'll be able to get through most of them. Okay. So if you look at 1 and 3, they already do the hard part for us. Like it's already factored, it's already set equal to 0. So all we have to do is set each factor equal to 0 and we're good. So k plus 1 equals 0. K equals -1. And if I set k minus 5 equals 0, I get that k is equal to 5. All right, and number 3, again, they've already done the hard part for us. I just have to set each of these equal to 0. Because if either 4k plus 5 is equal to 0 or k plus 1 is equal to 0, I know that my whole equation will be equal to 0. So k is either going to be equal to -1, or on this side, let's see, 4k is equal to -5. So then if I divide by 4, I get that k is equal to -5 over 4. Let me see if I can write that a little nicer. All right, but notice that things get a little bit harder when we get to number 5, right? So there are a couple of things that I noticed. First of all, my right side of my equation doesn't say 0 anymore, right? And also, my equation isn't factored yet. So both of those are going to be a problem that I'm going to need to overcome if I want to be able to solve this. The fact that the right side isn't 0 is a problem because, well, I don't really have like a property that helps me solve things to get -5. You know, I just have something that helps me solve things if I'm trying to equal something to 0. So the first thing I'm going to do is add 5 to both sides so I can get the right side back to equaling 0. So that gives me x squared minus 11x plus 24 equals 0. Next thing I want to do is I want to factor this. So I'm trying to find two numbers that multiply to be 24 and add to be -11, which would be -3 and -8. So x minus 3 and x minus 8. So then we get that x is either equal to 3 or x is equal to 8. And I'm done. So basically, if I had to write steps for this, the first thing we always want to do when we're solving quadratic equations by factoring is we want to set one side equal to 0. And then after I do that, I want to factor. Then I'm going to set each factor equal to 0. This keyboard doesn't like me today. And solve. That's really all there is to it. Okay, so looking at number 7, so going in order, my first step is to set one side equal to 0. So that's pretty easy if I just add 2 to both sides. So n squared minus 10n plus 24 is equal to 0. Next, I'm going to factor. So 2 numbers that multiply to give me 24 and add to give me negative 10. I actually need to think about this for a second. So if anyone thinks of it before I do, feel free to let me know. All right, -4, -6. Then if I set each of these equal to 0, I get that either n is equal to 4 or n is equal to 6. All right, number 9, I'm going to subtract 6 from both sides to get the left side to be 0. Notice that 6, -18, and -24, there's a GCF I can pull out. Anyone know what it is? Yeah, good, it's 6. Which leaves me with n squared minus 3n minus 4. So now I'm trying to figure out 2 numbers that multiply to give me -4 and add to give me -3. So that would be n minus 4 and n plus 1 equals 0. Okay, well 6 is never equal to 0. If I'm setting each factor equal to 0, I know 6 is never 0, so I can just ignore that. If I set n minus 4 equal to 0, I get that n is equal to 4. And if I set n plus 1 equals 0, I know that n is equal to -1. Okay, looking at number 11, first thing I have to do is set each side equal to 0. So I'm going to add 15 here, add 15 here. I get that n squared plus 8n plus 15 is equal to 0. If I factor this, I get n plus 3 times n plus 5 equals 0. So setting either of those equal to 0, I get that either n is equal to -3 or n is equal to -5. Notice that for each of these, I'm getting 2 answers, just like I said I would. All right. 13. So I need to get rid of everything on this side, so I'm left with 0. So I'm going to add 5k squared, add 5k squared, and I'm going to also add 3 over, add 3 over, which leaves me with k squared Okay, no plus. Minus 8k. And then I know the negative 3 and the positive 3 just cancel out. Here I can factor by using GCF. So I can factor a k out. And I'm left with k minus 8 on the inside. So then either I have k is equal to 0 or k is equal to 8. Once I set both of those factors equal to 0. Okay, next one's a little harder because it looks like we finally ran into a problem that has a greater than 1. So again, I'm just going to get the right side to be equal to 0. So 3r squared minus 16r minus 12 equal to 0. I'm going to find a way that I can split this middle term. So I need two numbers that multiply to give me negative 36 and add to give me negative 16. That would be negative 18 and positive 2. So 3r squared minus 18r plus 2r minus 12 equals 0. Going to break those two off, break those two off. So I end up with 3r times r minus 6 plus 2 times r minus 6, which is the same as saying 3r plus 2 times r minus 6 equals 0. And then last but not least, I want to set each of those factors equal to 0. So setting 3r plus 2 equal to 0 and r minus 6 equal to 0, I get either 3r equals negative 2, so r is equal to negative 2/3, or r is equal to 6. Okay, last three, we're almost there. So again, I'm just going to take 3 away from both sides, set the right side equal to 0. It looks like I have two terms. So typically when I have two terms, that's a sign that I'm going to want to factor by GCF. And if I set both of these equal to 0, I get either that k is equal to 0, or if you did the math out here, k is equal to 6/7. All right, 19 they already have equal to 0, so we just have to factor out a GCF. So x times 7x plus 2 equals 0. Setting each factor equal to 0, x can either be equal to 0, or x can be equal to negative 2/7. All right, and last but not least, 21. So I'm going to add 59x to this side and add 59x to this side. So I get the 8x squared plus 59x plus 21 equals 0. So two numbers that multiply to be 8 times 21 and add to be 59. I'm going to take a second to think about that. Let's see. So I have to multiply to be 128, add to be 59. Multiply to be 168, add to be 59. Oh, it ends up being 3 and 56. Okay, so then I'm going to break 59x into 3x plus 56x. And then take an x out. And then let's see, so I have x groups of 8x plus 3 plus 7 groups of 8x plus 3. Then x is either equal to -7 or x is also equal to -3/8. All right, and I think that's enough practice for one day. So once again, I'm gonna go ahead and pull the link so that y'all can practice more on your own if you want. Just give me 1 second to pull that up. And then after that, we'll call it a day. All right. Okay, so in case anyone wants it, here's the link. For those of you who are watching a pre-recorded version of this, clearly that link won't work. But feel free to pause the video and copy that URL, and that should take you to this page. Or also feel free to reach out to your center director if you want the link to that page. All right. Hope everyone has a good one. Till next time.